Now it's your turn to solve a system of linear equations using the elimination method. Stop this video, take a moment to write out your answers to this problem in your lecture outline packet, and then turn the video back on to check your answers. In this video, we're going to solve the system of linear equations using the elimination method. And the system we're going to solve is given by 3x plus 5y equals 8 and 2x minus 10y equals 12. To start, we want to look at the coefficients on each of our variables. With x, we have a coefficient of positive 3 and a coefficient of positive 2. With y, we have a coefficient of positive 5 and a coefficient of negative 10. Neither of those variables can be immediately eliminated, so we're going to need to build at least one of these equations. Looking at y, seeing that 5 is a factor of 10 is going to mean that that variable will be easier to work with, to eliminate. All that I'll have to do is build that first equation so that it has 10y. So what I want with that first equation is 10y. Now, to get there, I will need to build equation 1. And to get 10y when I have 5y, I'll need to multiply each side by 2. So I'll have 2 times the quantity 3x plus 5y equal to 2 times 8. And that'll give me 6x plus 10y equaling 16. Now I can write my system, when it's built up, as 6x plus 10y equals 16, and 2x minus 10y equals 12. And I can see now that when I add the left-hand sides and I add the right-hand sides, that variable y will be eliminated. So I'll go ahead and do that. I'll add, and I'll have 6x plus 10y on the left, and I will add that 2x minus 10y. And that will give me, 6x plus 2x will give me 8x on the left. Looking at the right, I have 16 plus 12. I'm going to have 28. So, dividing each side by 8, I'll have 8x over 8 equaling 28 over 8. And so x will then be 7 over 2. Now that we've determined the value of x, we can replace x in either of those original equations with that value and solve for y. So we'll now find y. And again, I can go back to either equation, a built-up equation, one of the originals. In this case, I'm going to take that second equation of 2x minus 10y, and I'm motivated by that coefficient of 2 and my denominator of 2. Again, any of them would work. Some will involve a little more arithmetic than others, though. So I'll take 2x minus 10y equals 12, and I'll use x equal to 7 halves. So I'll take 2 times that 7 halves minus 10y equals 12. 2 times 7 halves will give me 7. So 7 minus 10y is going to equal 12. Now when I subtract 7 from each side, I'll get negative 10y equal to 5. I'll divide each side by a negative 10. So negative 10y over negative 10 will equal 5 over negative 10. And that will give me y equal to negative 1/2. So I have that the value of x is 7 halves, the value of y is negative 1/2. I want to check into each of those equations. So I'll check into the first equation. I'll check does 3 times 7 halves plus 5 times negative 1/2 equal 8. And simplifying that left-hand side, 21 over 2 for 21 halves plus a negative 5 halves. I'm checking, does that equal 8? And 21 halves plus negative 5 halves will give me 16 halves, which indeed equals 8. Checking my second equation, 2 times 7 halves minus 10 times negative 1/2. I'm checking, does that equal 12? And 2 times 7 halves will give me 7. Negative 10 times negative 1/2 will give me positive 5. So I have 7 plus 5 equal to 12, and that checks. As a final step, I'll state my solution, and I can state this as an ordered pair with x and y. So I'll say then that the solution is the ordered pair 7 halves, comma, negative 1/2. If I wanted, I could also state the solution set, which would simply involve putting that ordered pair into a solution set. So the solution set is the set containing the ordered pair with 7 halves and -1/2.